Bismillahirrahmanirrahim. We are studying chapter 7, that is steering system, and we have covered the part 1. Today we will cover the part 2 of chapter 7, that is the steering system. First, the basic slide of this course of automotive technology. The power flow or the powertrain of a conventional rear-wheel drive vehicle, in which we have the engine from where the power is developed, then goes to the flywheel, then clutch, assembly and the gearbox, transmission, propeller shaft, differential box, and then distributed to the right and left wheel, which we have covered in our previous chapter, along with brake and suspension topics. Now today's topic is the steering system, and we have covered the first part. Now today, first a quick recap which we have studied in first part. First, the major parts of the steering system. There are 4 major parts of the steering system, that is steering wheel, column, gear, and linkage. We have talked about the steering wheel. The steering wheel, which consists of a rigid rim and number of spokes connecting the rim to a center hub, attaches to the top of the steering shaft at its center. And then we have talked about the airbag, how the airbag is incorporated in the steering wheel, what is the function of the airbag and how it explode and how much time is take, and what are the safety features which are there incorporated in the airbag. And this is how it's inflate and deflate. Then the second part was the steering column. Steering column is basically the second part which is joined with the steering wheel to the steering gears, and that the intermediate part or the part in between the gears and the steering wheel is the steering column. Basically, it's a long steering shaft which joins the both parts and the different detail parts of the steering column. And then we have talked about the detailed components of the steering column, in which we have talked about the column cover, and I want to show you the figure. Last time I haven't shown you the figure. So this is the steering cover. The figure steering column cover are often like this. And then we have talked about the collapsible steering column, and this is like this. We have a mesh arrangement which is easy to break, and it is attached to the breakaway support brackets. Then the last one was the tilt angle. These are the tilt lever and tilt ball, and this is tilt stop, which in the help of which we can tilt our steering mechanism. So coming back to the topic, then we have talked about further steering shaft, column, and then we talk about this flexible coupling, which is the last part of the steering shaft, which joins with the steering gears input shaft. And this was the part 1. Now today the part 2 of this chapter, and the third part of the steering system is the steering gear. Now the conventional steering gears, purpose and function. A conventional steering gear uses steering gear assemblies that moves linkages and sports arm to steer the vehicle. So a conventional steering gear uses steering gear assembly that moves linkages and sports arm to steer the vehicle. All steering gears have an input gear which transmits rotary moment from the steering wheel into the steering gear, and an output gear which causes the steering linkages to move laterally. Linkages are the fourth part of the steering system. Third is the steering gears. So all the steering gears have an input gear which transmits rotary moment. Rotary moment is coming from your steering wheel. We are turning the wheel clockwise or anti-clockwise or counterclockwise, and that rotary moment is now shifting to the steering column. From that steering column, it is coming to the steering gear, that from input steering gear, and that goes to the output steering gear, and which causes the steering linkages to move right and left laterally. The rotation of the steering wheel is transferred to the front wheels through a steering gear and linkages. The intermediate shaft is spliced to a worm gear inside a conventional steering gear. Around the worm gear is a nut with the gear teeth that meshes with the teeth on a section of a gear called sector gear. We will see in next slide in the figure how it looks like. The intermediate shaft is splined to a worm gear inside a conventional steering gear. Around the worm gear is a nut with the gear teeth that meshes with the teeth on a section of a gear called sector gear. The sector gear is a part of a pitman shaft. The sector gear is a part of a pitman shaft, also known as sector shaft, as shown in figure. So this is the figure. As the steering wheel is turned, the nut moves up or down on the threads, showing using a bolt to represent a worm gear and the nut representing the gear nuts that meshes with these teeth of the sector gear. So this is the where you have a pitman shaft. Input gear is this, and this is the worm gear or sector gear where we move right and left. We are giving input here and getting output in this direction. So pitman shaft is attached here. This is the sector gear, and this is the worm gear shaft, and this is the gear nut. So it moves like this. We are having a rotary motion here. That rotary motion is going to give converting into lateral motion in here with the help of this worm gear shaft. Now, steering gear ratio, the most important or the interesting part in this steering mechanism. When the steering wheel is turned, the front wheels turns on their steering axis. If the steering wheel is to rotate 20 degree and result in the front wheel rotating 1 degree, then the steering gear ratio is 20:1 or read as 20:1. Now I read again. When the steering wheel is turned, this is your steering wheel is turned, the front wheels turns on their steering axis. So the front wheel, these are your front wheel, they turns on their steering axis. If the steering wheel is rotated 20 degree, now if we move this steering wheel to 20 degree and the results in the front wheel rotating 1 degree and the result we are getting on the wheels is of 1 degree, then the steering gear ratio is 20:1. Read as 20:1 like in this figure. The front wheel usually are able to rotate through 60 to 80 degree of rotation. So these front wheel can rotate up to 60 to 80 degree of rotation on both directions. Okay. The steering wheel therefore has to rotate 20 times the number of the degree that the wheel moves. So if the wheel moves 60 degree here, this steering wheel has to move 20 times more the 60 degree of the wheel. So the steering wheel therefore has to rotate 20 times the number of degree that the wheels move. So 20 into 60 degree is equal to 1200 degrees or about 3 full revolutions. 360 degree is equal to 1 full turn of the steering wheel. So our steering wheel has to turn 3 complete full turn to achieve the 60 degree of the wheel rotation. Now, if it's 20 into 80 degree, it means 1600 degrees or over 4 revolutions of the steering wheel. So then our steering wheel has to turn over 4 revolutions to achieve that 80 degree. The steering gear ratio is the ratio between the number of the degree of the steering wheel is rotated to the number of the degree of the front wheel turn. Now, that was 20:1, the fixed steering gear ratio. When we have variable gear ratio, most steering gears have some rack and pinion steering gear features as variable ratio. This feature causes the steering ratios to decrease as the steering wheel is turned from the on-center position. So the higher on-center ratio, such as 16:1, provides good steering feel at highway speeds, while the reduced off-center ratio 13:1 provides fewer steering wheel turns during turning and parking. The ratio is accomplished by changing the length of the gear teeth on the sector gear. Now let's see this first figure. Both the teeth, all the 3 teeth have the same thickness and length. So the addendum and addendum of these teeth are of same dimension. So constant ratio steering gear sector shaft. Notice that all the three gears teeth are the same size. Now in this figure, the down below, the variable ratio steering gear sector shaft. Notice the larger center gear teeth. We have difference of thickness here as compared to these two teeth. So we will have the variable ratio in this arrangement. Now recirculating ball steering gear, we have a typical manual recirculating ball steering gear. This is the point, the pitman shaft point, where we have the input or the sector shaft. And this is your warm gear, the warm gear, warm shaft, the oil seals which are holding the oil here. And then we have a ball and guide arrangement here. Now another shape is the rack and the pinion steering gear mechanism. We have a rotary input from steering shaft. So this is the input steering shaft. We have a rotary input from this, and then we have this pinion and which is on the rack, and this rack move back and forth movement of the rack. So this is the steering input shaft. So this rack and pinion steering gear operation is simple, direct, and the track is in straight line to the front wheels. So this is another arrangement. Further illustration of this rack and pinion steering gear. A typical manual rack and pinion steering gear used in a small front wheel drive vehicle. We have this steering shaft coming in, and we have this pinion here, which is mount going inside here, and this is the rack on which this pinion is traveled. And on this is the left side, or and this is the right side, or you can say this is the right side or this is the left side, same arrangement. We have this housing, steering gear housing, then we have this rubber pad and tab washer. This is the inner rod, the tie rod and the boot clamp, and this is the boot, and this is going to the your tie rod end, and that tie rod end is attached to your steering knuckle, and that steering knuckle is attached to your wheel. And same goes on the this side. So these are the steering gear input shaft and the cover extra things. Now the last part of the steering system, that is the steering linkages. First was the steering wheel, then the steering column, then steering gears, and then steering linkages. Parts and operation. The steering linkages relays steering forces from the steering gear to the front wheels. Most conventional steering linkages use the parallelogram type design. So the most conventional steering gear linkages use the parallelogram type design. A parallelogram is a geometric box shapes where the opposite sides are parallel and equal distance. A parallelogram, as from the knowledge of your geometry, you know that a parallelogram is a geometric box shape where opposite sides are parallel and equal distance. A parallelogram type linkages uses four tie rods, two inner and two outer, left and right, a center link between the tie rods, and an idler arm on the passenger side, and idler arm on the passenger side. Remember this thing. And the pitman arms attached to the steering gear output shaft, pitman shaft. The center link may also be known by the several names, including following. We may call it as a center link, connecting link, or drag link, or connecting rod, relay rod, or intermediate rod. So the center link may also be known by these several names. That is center link, connecting link, drag link, usually a truck term only, then connecting rod, relay rod, or intermediate rod. How it look like? We have an arm here. Here we have a input here from gear mechanism. Then we have this center link, and this is the idler arm, which is on the passenger side. Then we have these four tie rods, and this is the outer tie rod end, right and left, and these are two inner tie rods end. The steering movement is transferred from the pitman arm. So this is your pitman arm from where the steering movement is transferred from the steering wheel to this steering linkage. That is splined to the sector shaft, pitman shaft. through the center link. This is your center link and tie rod ends, and these are your tie rods ends, and this idler arm is on your passenger side to the steering knuckle, and this the tie rod ends are linked to your steering knuckle at each front wheel. The idler arm supports the passenger side of the center link and keeps the steering links level with the road. So basically the function of this idler arm in this steering linkages is to support the passenger side of the center link and keep steering links level with the road. This type of linkage is called parallelogram design types. So with this, we comes to the end of our part 2 of our chapter 7, that is the steering system. Thank you very much.